Hey everyone, and welcome back to your GED Science Prep with the Dr. Cool Cat team. I am so excited for today's session because we are about to tackle one of the biggest ideas in all of Earth science, plate tectonics. Seriously, this one idea explains almost everything, from earthquakes to volcanoes to giant mountain ranges. So let's get right into it. So, have you ever just stared at a world map and noticed something kind of weird? Like, if you look at the coast of South America and the coast of Africa, they look like they could just snap together, like two perfect puzzle pieces. Well, that's no coincidence. In fact, it's one of the biggest clues we have to understanding how our entire planet is put together. And the answer to that puzzle is the theory of plate tectonics. You can think of this as the master key that unlocks how our planet works. The main idea is this: the Earth's surface isn't just one solid piece of rock. Nope, it's actually broken up into these enormous giant slabs called tectonic plates, and they're all slowly floating and drifting around. It's this movement that explains everything: earthquakes, volcanoes, you name it. Okay, so let's get into the good stuff. If these giant plates are constantly moving, what happens when they run into each other? Well, that meeting point is called a boundary. And trust me, that's where all the action happens. There are three main types, and knowing them is going to be absolutely crucial for your GED science test. First up, we've got divergent boundaries. The key word to remember here is divide. It's super simple. At these boundaries, two plates are literally pulling away from each other. They're diverging. The best way to picture this is to think of a giant zipper opening up super slowly right on the Earth's surface. As those plates pull apart, that super hot magma from deep inside the Earth rises up to fill the gap. It cools, it hardens, and bam, you've got brand new crust. So for your test, this is the takeaway. What do divergent boundaries actually create? Well, first, we just said it. They form new crust. This process also creates these massive underwater mountain ranges called mid-ocean ridges. And if this happens on land, you get these huge, deep valleys called rift valleys. All right, next up is pretty much the exact opposite: convergent boundaries. If divergent means divide, you can probably guess that convergent means collide. This is where two plates are on a collision course, smashing right into each other. Now, here's the interesting part. What happens when they collide depends on what kind of plates are crashing. If you have a really dense, heavy ocean plate hitting a lighter continental plate, the ocean plate gets forced to sink down underneath. That process is called subduction, and all that heat and pressure creates volcanoes. But what if two continental plates collide? Well, neither of them wants to sink, so they just buckle and crumple and push upward, forming these absolutely massive mountain ranges, like the Himalayas. And that brings us to our third and final type, the transform boundary. The key word here is slide. At these boundaries, the plates aren't colliding, and they're not separating. Instead, they're just grinding past each other horizontally. Just imagine rubbing two pieces of sandpaper together. That's the idea. Now, this sliding is anything but smooth. The edges of these plates are really jagged and rough, so they get stuck, they snag on each other, and as they try to keep moving, they build up an incredible amount of stress and energy. Eventually, something's got to give, and when all that stored energy is suddenly released, it causes a powerful, violent shaking that we feel as an earthquake. So, a planet made of moving puzzle pieces? That's a pretty wild idea, right? You might be wondering, how do we actually know any of this is true? Well, the evidence is pretty much overwhelming, and you'll definitely want to know the basics. The proof is literally all over the globe. First off, you have fossils. Scientists have found fossils of the exact same ancient plants and animals on continents that are now separated by thousands of miles of ocean. Then there are the rocks themselves. Entire mountain ranges on different continents, like in North America and Europe, line up perfectly if you just push the continents back together. And finally, the real smoking gun: seafloor spreading. Scientists found that the youngest, newest rock on the ocean floor is always at these mid-ocean ridges, and it gets older and older the farther you move away. That's proof that new crust is constantly being made right there. Okay, this is my favorite part. This is where we take all this knowledge and turn it into actual points on your test. For the GED, you need to be able to quickly connect an event, like an earthquake, with the right boundary type. And for that, we have the perfect secret weapon: the hand motion memory trick. Seriously, I want you to do this with me right now. It builds muscle memory, I promise. Okay, first, for divergent, put your hands together and pull them apart. That's divergent. Easy. Next, for convergent, push your hands together like they're crashing into each other. Feel that pressure? That's what builds mountains. And finally, for transform, put your hands flat, side by side, and slide them in opposite directions. Feel that grinding motion? That's your earthquake. All right, you know the concepts, you've learned the trick. Now let's put it all together and see how this works on a real GED-style question. This is how you're going to walk into that test feeling super confident. Okay, so here's our question. It says, the San Andreas Fault in California is a famous zone where major earthquakes frequently occur. The Pacific Plate and the North American Plate move sideways past one another along this fault. What type of plate boundary is this? Go ahead, take a second and think about it. So how do we solve this? First, we hunt for keywords. The two biggest clues here are earthquakes and move sideways past one another. Now, use the hand trick. Which one of our hand motions was the sideways one? That's right, the sliding motion. And what did we say that sliding, grinding motion causes? Earthquakes. So the connection is crystal clear. Sideways sliding means a transform boundary. The answer has to be C. And just like that, you nailed it. See how easy that was? By finding those keywords and using that simple hand motion trick to link the action to the result, you now have a foolproof way to solve any plate boundary question the GED throws at you. You have absolutely got this. Okay, now it's your turn. Looking back at that question we just did, what was the key phrase that made it all click for you? Was it hearing the word earthquakes, or was it the description moves sideways? Drop a comment below and let us know which phrase was the biggest giveaway for you. It's a great way to lock in what you just learned. And that's a wrap on plate tectonics. If this explainer helped things make more sense, do us a favor and hit that thumbs up button. And of course, subscribe for more prep sessions from the Dr. Coolcat team. Keep up the fantastic work, and we'll see you in the next one.